Hello learners, today we shall continue with chapter 9, coordination compounds. Dear learners, after today's discussion you will be able to recall the term coordination compounds, appreciate the need and importance of Iupac in naming of coordination compounds. You will learn the rules of nomenclature of coordination compounds. You will be able to write the formulas and names of mononuclear coordination compound. In the previous module, we have learned about the importance of coordination compounds in our daily life and the terms related to the coordination compounds. We all know from our previous knowledge that a coordinate compound is one in which the central metal ion in the complex forms dative, coordinate covalent bonds with the species surrounding it. Let us begin with recalling these terms. For the given complex, let us work out the following. The central atom or the ion is chromium 3 plus here. Ligands and their types is ammonia and water. Both are neutral and monodentate ligands. The oxidation number of central atom or ion here is +3. We need to know whether the given complex is homoleptic or heteroleptic. Yes, it is heteroleptic because the ligands are of different types. The primary valency here is +3 as the ionizable chloride ions are here 3. Secondary valency is 6 as well as the coordination number, which is also 6. Nomenclature is important in coordination chemistry because of the need to have an unambiguous method of describing formulas and writing systematic names, particularly when dealing with the isomers. The formula and names adopted for coordination entities are based on the recommendations of the International Union of Pure and Applied Chemistry, commonly known as Iupac. Let us now learn how to write formulas of mononuclear coordination entities, that is, containing a single central metal atom. The formula of a compound is a shorthand tool used to provide basic information about the constitution of the compound in a concise and convenient manner. The following rules are applied while writing the formulas. Let us take them one by one. The central atom is listed first. The ligands are then listed in alphabetical order. The placement of a ligand in the list does not depend upon its charge. Polydentate ligands are also listed alphabetically. In case of abbreviated ligands, the first letter of the abbreviation is used to determine the position of the ligand in the alphabetical order. The formula for the entire coordination entity, whether charged or not, it is enclosed in square brackets. When ligands are polyatomic, their formulas are enclosed in parentheses. Ligand abbreviations are also enclosed in parentheses, where there should be no space between the ligands and the metal within a coordination sphere. When the formula of a charge coordination entity is to be written without that of counter ion, the charge is indicated outside the square brackets as a right superscript with the number before the sign. For example, in the given complex, the charge is indicated as 3- above on the right hand side of the square bracket, while in the other one it is indicated as 3+ on the right hand side of the square bracket. The charge of the cation is balanced by the charge of the anions. For example, let us write the formula of the following compound: pentaamine chlorocobalt 3 chloride. Now, to write the formula, the first rule says write the central atom first, and that is cobalt here, the symbol CO. Then write ligands and their number, that is amine, and they are 5 in number, making it NH3 whole 5. Now enclose in square brackets with no space in the central atom and ligands. Then balance charge by the number of anions here. 3 as oxidation state of cobalt is +3, and amine being a neutral ligand, therefore 3 chloride ions balance it. Hence the formula for the given complex is CO NH3 brackets closed Cl3. Now that we have learned how to write the formula of a coordination compound from its Iupac name, let us try naming of mononuclear coordination compounds whose formula is given to us. The names of the coordination compounds are derived by following the principles of additive nomenclature. Thus, the groups that surround the central atom must be identified in the name. They are listed as prefixes to the name of the central atom along with any appropriate multipliers. Nomenclature of coordination complexes, Iupac conventions. Let us learn them one by one. For any ionic compound, the cation is named before the anion. If the complex is neutral, the name of the complex is the name of the compound itself. In naming a complex which may be neutral, a cation or an anion, the ligands are named before the central metal atom or ion. The ligands are named in alphabetical order. Prefixes are not counted. The number of each type of ligands are specified by the Greek prefixes. For example, 1 stands for mono, 2 di, 3 is represented by tri, tetra for 4, penta for 5, hexa for 6, and so on. When the names of the ligands include a numerical prefix, then the terms like bis for 2, tris for 3, and tetrakis for 4 are used, the ligands to which they refer being placed in parentheses. For example, the complex given here is named as dichlorido bis triphenylphosphine nickel 2. The oxidation number of the metal ion in the complex is indicated immediately after the name of the metal using Roman numerals. Let us learn how to write the name of given complexes one by one. The first complex given here is named as tetra-aqua dichloro chromium 3 chloride. The next one is triamine trichloro cobalt 3. The next complex shown here is potassium hexacyanoferrate 3. The naming of the anionic ligands always end in O. For example, CN becomes cyno or cynido, Cl becomes chloro or chlorido, bromide ion becomes bromo, I is called ido, OH minus becomes hydroxo, NO2 minus is nitrito, SO4 minus is called sulfato, and H minus becomes hydrido. Please note that the 2004 Iupac draft recommends that anionic ligands will end with ido, so that chloro now would become chlorido. The 2004 Iupac draft recommends that ligands will be sorted alphabetically irrespective of the charge. The names of the neutral ligands are the names of the molecules except the following. Let us note that certain neutral ligands like ammonia NH3 are called amine. Water is called as aqua. Carbon monoxide becomes carbonyl, whereas nitrogen monoxide is called nitrosyl. If the complex is anionic, then the suffix "ate" is added to the end of the name of the metal, followed by the oxidation number of that metal formula. For example, cobalt in a complex ion given here is called cobaltate. For some metals, the Latin names are used in the complex anions. For example, ferrate for Fe. The given complex here is hexacyanoferrate 3 ion. If the complex is cationic or neutral, then the name of the metal is unchanged, followed by the oxidation number of that metal. For example, the given complex is tetra-aqua dichlorido chromium 3 ion. Ligands which can ligate through two different atoms are called ambidentate ligands. Examples of such ligands are NO2-. The nitrite ion can coordinate either through nitrogen, thus named as nitrito-N, or through oxygen to a central metal atom or ion, thus named as nitrito-O. The following examples illustrate the nomenclature for coordination compounds. In the first complex given here, it is named as triamine triaqua chromium 3 chloride. Let us understand how we have named this complex. The complex ion is inside the square bracket, which is a cation. The amine ligand are named before the aqua ligands according to the alphabetical order. Since there are 3 chloride ions in the compound, the charge on the complex ion must be +3. Since the compound is electrically neutral, from the charge on the complex ion and the charge on the ligands, we can calculate the oxidation number of the metal. In this example, all the ligands are neutral. Therefore, the oxidation number of chromium must be the same as the charge of the complex, that is +3. The second complex given here is named as tris-ethane 1,2-diamine cobalt 3 sulfate. Let us understand how we have named this complex. The sulfate is the counter anion in the molecule. Since it takes 3 sulfates to bond with 2 complex cations, the charge on each complex cation must be +3. Further, ethane 1,2-diamine is a neutral molecule, so the oxidation number of cobalt in the complex ion must be +3. Remember that you never have to indicate the number of cations and anions in the name of an ionic compound. Let us learn naming of another coordination compound where both cation and anion are the coordination entities. It is named as diamine silver 1, dicyanoargentate 1. Please notice how the name of metal differs in cation and anion even though they contain the same metal ion. Let us quickly summarize what we have learned today. We have learned writing the formula of coordination compounds, and we have learned Iupac nomenclature of coordination compounds. Well, there is lot more to learn about coordination compounds, which we shall take up in modules to follow. Before we end today's discussion, let me leave you with an assignment. Write the formula of the following compounds. The first one, diamine chlorido nitrito N platinum 2. The second complex here is potassium trioxylato chromate 3. The third one is dichlorido bis ethane 1,2-diamine cobalt 3 chloride. Pentaamine carbonato cobalt 3 chloride. And the last one, mercury tetrathiocyanato cobaltate 3. Also write the Iupac name for the given complexes. I hope you have understood the concepts discussed today. Thank you.